Smartphones have transformed our lives in ways few devices ever have. From connecting us with friends and family to serving as our cameras, navigation tools, entertainment centers, and even personal assistants, smartphones have become an indispensable part of daily life. But have you ever stopped to wonder how these marvels of technology are actually made? The journey from an idea on a designer's sketchpad to the sleek, powerful device in your hand is a testament to human ingenuity, global collaboration, and cutting-edge engineering. Let's take an in-depth look at the fascinating process of how smartphones are made, from the drawing board to your pocket. The journey of a smartphone begins long before any physical object takes shape. It all starts in the design and planning stage, a phase that can last months or even years. Here, teams of industrial designers, hardware engineers, and software developers work closely together to bring a new vision to life. Industrial designers start by sketching out concepts, building digital 3D models, and creating physical prototypes. Every curve, edge, and surface is carefully considered. They debate over screen size, the placement of buttons and cameras, and the overall aesthetics, balancing beauty with practicality. The goal is to create a device that not only looks good, but feels comfortable in your hand. Meanwhile, hardware engineers focus on the phone's internal architecture. They meticulously plan out how to fit advanced components, like processors, batteries, camera modules, and sensors, into an increasingly slim and compact frame. Each millimeter counts, and every gram is scrutinized. Engineers must ensure that all the parts work together seamlessly without causing the device to overheat or run out of battery too quickly. At the same time, software developers are hard at work customizing and optimizing the operating system, whether it's Android, iOS, or a proprietary system. They tailor the software to leverage the new hardware's capabilities, ensuring a smooth, responsive, and secure user experience. Before moving to the manufacturing stage, prototypes undergo a battery of rigorous tests. Stress tests, drop tests, and thermal analysis are performed to make sure the phone can withstand real-world use. Only after passing these trials does the design get the green light for production. Once the design is finalized, the next step is sourcing raw materials. Modern smartphones require a dazzling array of materials sourced from around the globe. Metals like aluminum and copper form the structural frame and internal circuits. Precious metals such as gold and tantalum are used for connectors and microchips, while rare earth elements like neodymium and dysprosium power tiny but powerful magnets found in speakers and haptic engines. Lithium and cobalt, often mined in countries like Australia and the Democratic Republic of Congo, are essential for the rechargeable batteries that keep our phones running all day. Silicon, extracted from sand, is the foundation of the processor and memory chips. Even the display requires specialized materials, ultra-strong glass, sometimes bonded with sapphire for scratch resistance, and organic compounds for OLED screens. With raw materials in hand, it's time to create the core components that bring the smartphone to life. The processor, often called the brain of the phone, is a marvel of modern engineering. Companies like Qualcomm, Apple, or MediaTek use a process known as photolithography to etch microscopic circuits onto silicon wafers. These wafers are processed in clean rooms, where even a single dust particle can ruin a batch of chips. The result is a tiny but incredibly powerful system-on-chip, SoC, that can handle billions of calculations per second. The display is another technological wonder. Most high-end smartphones use OLED or AMOLED displays, which are built by layering thin films of organic materials between conductive tracks. When electricity passes through, these organic layers emit light, producing vibrant colors and deep blacks. A layer of toughened glass, such as Gorilla Glass, is fused on top to protect the screen from scratches and drops. Batteries are built in specialized facilities where lithium-ion or lithium polymer cells are assembled. These batteries are designed to be lightweight, compact, and capable of hundreds of charge cycles without significant degradation. Camera modules, meanwhile, are assembled from intricate arrays of lenses, sensors, and stabilizing elements. The highest-end models may include multiple cameras, wide-angle, telephoto, and macro, each offering unique photographic capabilities. At the heart of every smartphone lies the printed circuit board, or PCB. Building a PCB is a highly automated process. First, the board is coated with a solder paste. Precision robotic arms place hundreds of tiny components, resistors, capacitors, chips, onto the board. The assembly then passes through a reflow oven, where controlled heat melts the solder, permanently fixing the components in place. Each PCB is then tested for electrical functionality, ensuring that every connection works flawlessly. With the internals ready, attention turns to the smartphone's body. Most modern smartphones use metal frames, often made from aircraft-grade aluminum alloys. These frames are shaped using computer-controlled CNC machines, then polished and anodized for a sleek, durable finish. Some phones feature glass backs, bonded to the frame using powerful adhesives for a seamless look and feel. Plastic components are injection molded and finished to match the design. Every body is inspected for quality, with even minor imperfections leading to rejection or rework. Now comes the final assembly. In high-tech factories, robotic machines and skilled technicians work side by side on assembly lines. The display panel is attached to the frame with precision. The PCB, battery, and camera modules are carefully placed inside the casing. Flexible cables connect the screen, battery, and motherboard. For waterproof models, rubber gaskets and adhesives are applied to seal every gap. Finally, the rear panel, glass or metal, is glued or screwed into place. Every assembled smartphone undergoes a series of quality tests. Drop tests ensure the device can survive accidental falls. Batteries are subjected to safety tests to prevent overheating or explosions. Waterproof models are submerged in water to verify their IP rating. Every button, camera, and sensor is checked, and the touchscreen is calibrated for responsiveness. Only phones that pass these demanding tests move to the next stage. With the hardware certified, the operating system is installed. This involves loading the bootloader and main OS, Android, iOS, or another system, along with essential apps and security updates. Each phone is calibrated for maximum performance with sensors, cameras, and touchscreens fine-tuned to perfection. Finally, the finished smartphones are cleaned, polished, and carefully packed into boxes, complete with chargers, cables, and manuals. The boxes are sealed, labeled, and shipped to distribution centers around the world, ready for eager customers. The making of a smartphone is a global symphony of high-tech engineering, advanced robotics, and skilled human labor. From the mining of rare materials to the assembly of microscopic circuits and the installation of sophisticated software, each device is a masterpiece of modern manufacturing. So next time you pick up your phone, take a moment to appreciate the incredible journey it's been on. A journey powered by innovation, dedication, and the relentless pursuit of perfection.